数学是最赤裸裸的东西，它直接告诉你一个事情的一个现象的本质，背后的本质是什么。
And mathematics is really something that once you understand it, you can see the beauty of it. You can see the kind of creativity. For some things it's like art. If we think about everything which surrounds us, the technology, the laws of physics that describe what happens in nature, we can use them, we can do something with them. We have the technology that we have because there is mathematics. Mathematics has been the way for the human to understand phenomena.
That in fact, by now there are in fact many parts of mathematics which have become interesting for applications. So many more than a few decades ago.
应用往往是一门综合学科 ，even 在数学里面，你要解决一个应用数学解决问题，不是一个单门的理论数学可以解决，这实际上是一个系统工程，数学的系统工程。
So we are at a moment where I think the computational power, it's really at the maximal level, maybe a bit better, but nothing exceptional. It's not going to be like 1,000 times better. And but mathematically, as I say, there are many challenges, and I think once we will understand better how AI works, why it works, how to improve it, how to make it more efficient, safer, and everything, this is when we will see a next revolution.
I mean, if you have theory but without practical case, so you find, you kind of lose a sense of purpose. Whereas, here, if you do also the practice but without a good theory, well, you will continue on improving already known techniques, but you will not do something revolutionary. I mean, of course, you will advance the technology, but basically you will be in the same trend. I mean, we'll just add some new layer of refinement, but it will not be a step forward somehow.
So we think that, of course, when you are a theoretician, you are looking for understanding. But when you are an engineer, you are looking for something which works better. But then there is a miracle that usually when you get better understanding, you become more efficient. So here what we need is in some sense to enrich
Okay, I think it's time. Okay, let's start. Welcome to today's Trust Park Hour. We are honored to invite Professor Rahim Tafazolli today to present an innovative perspective on teleportation technology in communications. First, let me give an introduction about Professor Rahim. Professor Rahim is the Commander Order of British Empire and the only Regius Professor in Electronic Engineering. He is a Fellow of Royal Academy and a Fellow of Wireless World Research Forum. He is a Professor of Mobile and Satellite Communications at the Surrey University in the UK and is the founder and director of the world's first 5G Centre, known as 5G Innovation Centre, and also director of UK's first Centre on 6G. He advises many international industries and governments, including UK governments and local council. He represents UK Space Agency in ESA 5JAC and also is the chair of the ESA 5JAC. He has more than 30 years of experiences in wireless communications, since 2G and since the first generation of satellite PCN. Welcome, Professor Rahim.
Thank you, Lily. Thank you, and good day to everybody. I would like to share with you my views about future of intelligent wireless world. So as you see from the title, is a little bit futuristic, and under the title of how we can do teleportation and how the next generation of the communications like 6G and beyond are moving in that direction. First of all, I first presented the idea of teleportation in TEDx talk in 2015. And I said, in 30 years' time, when it was 2015, in 30 years' time, which is 2045, all science fiction books, films, and anything published so far are technically possible. Then I brought this challenge upon myself. I said, in this TED talk, I said, can we do teleportation? And then I explained the principle of how we can do teleportation. And this is the subject of today's seminar. So, a couple of years ago, I came across this quotation by Nikola Tesla, which he said this one nearly 100 years ago. And he said,
Hi,
when
Professor.
wireless is...
This is Lily, and I think the slides didn't turn to page 2 or page 3.
It's not changing now?
No, it's still on the cover page.
Oh. Okay, let me see what is the problem. How about now?
Still the cover page.
Oh. So it is changing in my screen.
Maybe we can restart the sharing of screen to try it again.
Okay, I stop sharing and I try to reshare again.
Yeah, thank you very much.
Share Windows.
数学是最赤裸裸的东西，它直接告诉你一个事情的一个现象的本质，背后的本质是什么。
And you know, mathematics is really something that once you understand it, you can see the beauty of it. You can see the kind of creativity. It's for some things it's like art. If we think about everything which surrounds us, the technology, the laws of physics that describe what happens in nature, we can use them, we can do something with them. We have the technology that we have because there is mathematics. Mathematics has been the way for the human to understand phenomena.
That in fact, by now there are in fact many parts of mathematics which have become interesting for applications. So many more than a few decades ago.
应用往往是一门综合学科。even 在数学里面，你要解决一个应用数学解决问题，你不是一个单门的理论数学可以解决，这实际上是一个系统工程，数学的系统工程。
So we are at a moment where I think the computational power, it's really at the maximal level, maybe a bit better, but nothing exceptional. It's not going to be like 1,000 times better. And but mathematically, as I say, there are many challenges, and I think
that in 30 years, all science fiction books, films, and everything's been published are technically possible. Then I brought this challenge upon myself. I said, perhaps you could ask, how can we do teleportation? And this is the subject of today. I'm presenting what I presented in the TED Talk, which is, it was about 10 years ago. So a couple of years ago, I came across the famous quotation by Nikola Tesla, which he said this one about 100 years ago. And I saw there is some synergy to what I was saying in 2015. And he said, when wireless is perfectly applied, the whole earth will be converted into a huge brain, which in fact it is, all things being particles of a real and arithmetic whole. We shall be able to communicate with anyone instantly, irrespective of distance. So I highlighted two of these points: huge brain and instant and connectivity irrespective of the distance. So if we go back in terms of communication and sensing history, we started.
数学是最
Okay.
Yeah, good.
So if we started many years ago, communication between people was like a smoke sign, or people were shouting and to convey the message, or is a telegraph, and then is a postal system, and then is wireless, and is a combination of all of this. But nevertheless, since the beginning until now, all the communication that we have been doing is using audio and video, or two of the human senses, which is hearing and seeing, voice, image, and video. Only two of the human senses. The question is, why can't we transmit other human senses, like touch, taste, and smell, in order to bring all the sensing and feeling of the presence to when we communicate? So The idea is transmitting sensing is more important than transmitting or teleporting a physical body. It could be hands or legs or limbs or flesh and bones. And senses are, or the 5 senses that we have, is what makes us us. As imagine that we are transmitting a physical body without senses, that doesn't mean anything. Whereas transmitting senses is everything that we feel, we taste, and we hear, and we see, and everything else. So instead of transmitting a physical body, why don't we transmit and receive senses? It is more feasible and more practical. So teleportation is, in addition to transmitting the human senses or the human 5 senses, we also need to transmit the image. And fortunately, the video, like the 2-dimension video and 3-dimension video, virtual reality, are mature enough to transmit the whole body as very, very high quality. In addition to the 5 human senses, we also need to transmit the ambient information, like the air quality, like the temperature surrounding us, the proximity us with other objects and other people, the background noise and the lighting and everything else, in order to give that impression of the presence anywhere with all the human senses. We can estimate image and activity very accurately. Now we have the technologies to do that, and with a high resolution. So transmitting image with a high activity, with a high resolution, localization and movement, together with the human senses, as well as the ambient information, it is possible to turn a science fiction teleportation into a science fact. So let's see where we are with the objective of the future communication systems, which we refer to as 6G, which is about to be introduced into market by 2030 and so on. In 6GIC at the University of Surrey in 2020, we said 5G is a very strong technology and it evolves with many features and many capabilities. So what should we do that makes a big difference between what 5G and its evolution is, as well as what is going to be upcoming 6G? Together with our industry partners, we said we need to solve the problem of coverage. And everywhere, universally, we need to provide broadband connectivity. Another aspect, we said, we need to bring sensing, which I will explain later on what it means, into the communication. And in addition, we need to bring time synchronization. So that's what we said 3 years before IMT 2030, which is referred to 6G, came up with this 6G wheel, and they said the same thing. They said we need ubiquitous connectivity, we need integration of AI into the communication, and we need sensing and communication all integrated. Obviously, we said the same thing. We said we use AI and bring the intelligence into the network for the network itself, as well as for new intelligence services for the people, for the users. So we said exactly the same thing. And we are very happy that community also agrees with the AI and the sensing and the coverage and time synchronization, which I will explain why we need time synchronization into the future networks. So
Hello,
this is a good
Professor.
start.
I'm sorry,
Yes.
we are still on the page of communications and census history.
Oh.
So would you mind turning the sharing page to the preview page, and then we will not make it a presenters mode, and then maybe we can see. Yeah, right now we see the 6G universal intelligent connectivity. Is that right? I don't know, is 6G is the title? Yes, that's the page I'm on. Oh, yes, okay. Then I think you need to click the button. I don't know how it works, but like suddenly we are turning to like several pages in 1 second, and then for last 10 minutes of your presentation, it was still on the history page. Shall we start again with the 6G page right now?
Okay, can you see this 6G? I see an ITU vision.
No, I can see a 6G logo in the center of the PowerPoint with universal intelligent connectivity.
No, this is one page after this page.
Yeah, would you mind send the slides to me and let me share my screen, and then you can see my screen, and then when you say next page, I can turn the slides for you.
Oh, that's a good solution, but it takes time.
Yeah,
because the volume of.
Yeah, we will explain to our audience. Do you think how long would it cost?
Probably about 5 minutes to send it to you.
Yeah, okay, then we will turn it into the warm-up video and explain to our audience, and we will be back in 5 minutes.
Okay,
great, thank you.
Yeah, okay, bye.
数学是最赤裸裸的东西，它直接告诉你一个事情的一个现象的本质，背后的本质是什么。
And mathematics is really something that once you understand it, you can see the beauty of it. You can see the kind of creativity. For some things it's like art. If we think about everything which surrounds us, the technology, the laws of physics that describe what happens in nature, we can use them, we can do something with them. We have the technology that we have because there is mathematics. Mathematics has been the way for the human to understand phenomena.
That in fact, by now there are in fact many parts of mathematics which have become interesting for applications. So many more than a few decades ago.
应用往往是一门综合学科。even在数学里面，你要解决一个用应用数学解决问题，你不是一个单门的理论数学可以解决，这实际上是一个系统工程，数学的系统工程。
So we are at a moment where I think the computational power, it's really at the maximal level, maybe a bit better, but nothing exceptional. It's not going to be like 1,000 times better. And but mathematically, as I say, there are many challenges, and I think once we will understand better how AI works, why it works, how to improve it, how to make it more efficient, safer, and everything, this is when we will see a next revolution.
I mean, if you have theory but without practical case, so you find, you kind of lose a sense of purpose. Whereas, here, if you do also the practice but without a good theory, well, you will continue on improving already known techniques, but you will not do something revolutionary. I mean, of course, you will advance the technology, but basically you will be in the same trend. I mean, we'll just add some new layer of refinement, but it will not be a step forward somehow.
So we think that, of course, when you are a theoretician, you are looking for understanding. But when you are an engineer, you are looking for something which works better. But then there is a miracle that usually when you get better understanding, you become more efficient. So here what we need is in some sense to enrich the amount of mathematical knowledge of the computer scientists we talk with in order to make them realize that they can try to implement larger schemes.
就比如说是像那个大型语言模型，它里面最基础的模块是 transformer。transformer 实际上基本来说90%以上都是矩阵运算。这些矩阵运算我们如何给它加速？如果说我们能够加进很多数学的东西，就比如说利用好的矩阵分解、张量分解，利用比较好的核函数的设计，以及利用比较好的那个位置编码的方式，我相信是可以更有效的去加速整个大型语言模型的计算。
I studied mathematics. I developed new methods for solar physics. And then during conferences, I met people from cardiology. They showed their time series, their measurements, and looked very similar as solar activity. And then this is a way of interdisciplinary. Then we talked with each other and worked with each other. But the important point is each discipline has its own language, specific language. And the problem is that you have to learn, each side has to learn a bit the basic parts, not complete, but basic parts of the language of the others, that we really can communicate and that they can tell what are their real problems.
比如说可以从黄大年开始，比如黄大年可以提供一系列的数学的课程，比如说是一些跟那个 AI 相关的数学，或者说跟其他方面，跟研究物理、跟材料、化学都需要不同的数学。从最简单的方程式开始，慢慢一步步的把这个问题给解剖开来，往深的方向走，就看你的兴趣。觉得要有一个好的一个提供知识的平台，我觉得需要形成一个这样的机制。 数学是最赤裸裸的东西，它直接告诉你一个事情的一个现象的本质，背后的本质是什么。
And mathematics is really something that once you understand it, you can see the beauty of it. You can see the kind of creativity. For some things it's like art.
就是你是看不到我旁边的这个小框框的。但他还没上会。
你可以点第二个点那个模式啊。
我不会演讲中文。
If we think about everything which surrounds us, the technology, the laws of physics that describe what happens in nature, we can use them, we can do something with them. We have the technology that we have because there is mathematics. Mathematics has been the way for the human to understand phenomena.
That in fact, by now there are in fact many parts of mathematics which have become interesting for applications. So many more than a few decades ago.
应用往往是一门综合学科，even在数学里面，你要解决一个应用数学解决问题，不是一个单门的理论数学可以解决，这实际上是一个系统工程，数学的系统工程。
那我怎么一边 share screen 一边说我的主持？那我就让他直接开始讲吧，行不行？我前面说完了就帮我。Hi Professor. Yeah, could you see
Hello.
my screen?
Yes, I can.
And could you see I turning the next page of?
Yes.
So
yes, okay, great.
we are at the
Then
moment where I
shall
think
we
the
start from
computational
the
power, it's really at the level, at the maximal level,
great. Yeah,
maybe a bit
and,
better, but nothing exceptional. It's not
just
going to
give
be
me
like
5 seconds. We are
1,000
turning
times.
back to
It's not a full screen, It's not a full screen.
For you, it's not the full screen.
No.
Okay. Let me check it. Just give me a second. 他说对他来说，OK，
数学是最赤裸裸的东西，它直接告诉你一个事情的一个现象的本质，背后的本质是什么。
And mathematics is really something that once you understand it, you can see the beauty of it. You can see the kind of creativity. For some things it's like art.
Okay, then give me 3 seconds. 3, 2, 1. Good. You're ready to go. Yeah.
Okay, thank you. Sorry about the technical problem. Let me start from the beginning. What I would like to discuss and present to you is the future intelligent wireless world, and more specifically, how we can enable teleportation and how the next generation communication system is positioned to deliver the ultimate teleportation concept. Next page, please. The whole idea of the teleportation I presented in a TED talk in 2015, about 10 years ago. And I said in 30 years, all science, fiction, books, films, everything has been published so far are technically possible. We have the technology, or we are going to very quickly develop the technology to be able to implement and produce everything, every concept, every vision has been suggested in science fiction books and films. Then I brought this challenge upon myself. I said, I said to audience, you may ask, can we do teleportation? Teleportation is been a science fiction, and is it possible to do it technically? So, and that was the subject of my TED talk. Next page, please. Then, about a couple of years ago, I came across the famous quotation by Nikola Tesla, who said this quotation about nearly 100 years ago. And he said, when wireless is perfectly applied, the whole earth will be converted into a huge brain, which in fact it is, all things being particles of a real and arithmetic whole. We shall be able to communicate with one another instantly and irrespective of the distance. Then I said to myself, well, Tesla said the same thing or the same idea about nearly 100 years ago. So we want to see how we can, with the teleportation, what we need to do in order to achieve both teleportation as well as what Nikola Tesla has said about 100 years ago. Next page, please. So if you go back to communication and what senses that we have used from day one of people communicating with each other, starting from smoke, signs and shouting and telegraph and post, and then wireless, and everything we have done so far in terms of communicating between people in a short distance or long distance, we have used only voice and video or image, and recently more video. And this requires only two of the human senses, hearing and seeing. Only two of the human senses we have been using. So the question is, why can't we use other senses? And if we do other senses like touch, taste, smell, what happens? What would be the media? What would be the interactivity look like? So next page. So teleportation is how we can turn a science fiction into a science fact. We need to ask ourselves this question. For teleportation, what is more important to be teleported? Is it physical body, which is hands and legs and limbs and flesh and bones, or is it human senses, which is seeing, hearing, touch, taste, and smell? The question is, the fact is, we are our senses and our brain. It is not the shell or physical body that makes us us. The way we feel, the way we taste, the way that we feel happy or angry or whatever it is our senses. So the question was, why don't we transmit the senses to enable teleportation? Next page, please. So for teleportation, we also, in addition to human senses, all the 5 human senses, we need to transmit other ambient information like air quality, proximity, background noise, the lighting, and everything else around a person or an object. And also we need to transmit the person or object or robot's image and activity detection. And we have technology that we can easily develop an image with the radio waves of any object, as well as very high resolution activity detection, which is sitting, walking, hand gesture, or whatever it is. We can easily detect that. So next page, please. So how does the future wireless connectivity relates to this future concept and intelligent huge brain of Earth turning into a huge brain, as well as the connectivity. In 2020, together with our industrial partners of the members of 5G and 6G Innovation Center, we thought that 5G and its evolution is a very strong technology. So what do we need to add for 2030 to make the future communication? That's what the market needs and the people need. And we came up with an idea. We said we need to solve the problem of broadband coverage cost effectively, as well as highly energy efficient technologies. So the coverage was one of the areas we said. Then we said we need to bring sensing, which I will explain later on, into the communication, and it will enable many new services and applications, etc., which I will explain later. We also said we need time synchronization for the network itself to manage its resources, as well as enable new services. And we use AI and ML everywhere to make the whole system as intelligent as possible. So that's what we said in 2020. 3 years later, ITU, IMT 2030 said exactly the same thing. They said we need to do integration of sensing and communication. We need to look at and enable integration of AI into the communication. And we also need to make the connectivity ubiquitous and universal. So exactly the same thing. And also the time synchronization is written in IMT 2030 documents as well. So next page. So it's a good start. 6G will be a good start towards ultimate intelligent future wireless world. Just if you dig a little bit more into details, 6G would enable, with all these attributes, a physical and digital world interactivity. It will introduce more intelligence into the communications, and we need to bring sensing and communication together. We need to, in order to solve the problem of ubiquitous and universal connectivity, we need to have unification between a space like satellite communication, HABs, UAV, and terrestrial networks. This is the most cost-effective, highly energy-efficient way of doing it. As well as the future network will be integration between fixed and mobile system for indoor, outdoor system, and we utilize the technology that is been successful in IT industry and bring that one into telecom system. So if you want to define 6G, 6G is intelligent unification of all the connectivities. Thank you. Next page, please. So 6G is the beginning of a new era, which will see a turning point in the way that we work, we communicate, and we play. A broader understanding we need of sensing. What is sensing? And why sensing is important? Why AI is important? Why time synchronization is important? Communication. And most importantly, it is integration of all of this into one system that gives the value that we want from all of this together. Sensing helps AI. AI will not be very intelligent if we don't have the sensing data. And AI helps sensing, and so on, so, which hopefully during this lecture, it will become a little bit more clear. Next page, please. So if you look a little bit deeper, how should we design future networks? Do we need to define all the functionalities and all the services before standardization? Or should we follow a basic principle then which allows us to add functionality, add more intelligence, and etc.? So if you look closely, sensing effectively gives an eye to the network. So network does not to do blind resource management, blind interference cancellation, interference management, signal processing, etc. It will gives an eye to the network. Semantics and AI, it gives the brain to the network. Time synchronization and frequency synchronization, effectively, if the whole network is synchronized, is like a heartbeat for the whole network. Virtualization and open APIs or softwareization is a kind of freedom between software and underlying hardware. So it allows the network to evolve with all this intelligence and all this information. So perhaps for designing the future network, 6G and beyond, we need to adhere to these basic principles and implement them as efficiently as possible to allow future enhancement with services and functionalities. So if you look at all these attributes, what does it remind you of? It should remind you of a person, a baby. Next page, please. Oh, I think you missed one page, is it? Okay, next page. Okay, let's see how the Tesla huge brain can be delivered. Telco for AI. Telco is important for AI intelligence and learning and enhancing the capability. At the moment, the current large language models, they use about 95% of the internet data. And that is the intelligence that we have. We need, in order to enhance the intelligence of the AI, we need telco networks, which underpins most of the connectivities, industry networks, public networks, critical national infrastructure, hospitals, etc. Everything that brings huge amount of data, which would be useful for AI enhancement. And the data quality is more important than the volume of the data for learning, the AI learning. So connected AI will be more powerful and more intelligent than unconnected AI. And that's what telco can bring. And AI agents, which do specific jobs, specific functionalities, is highly energy efficient, reduce computation, and etc. and etc. So if we have these principles of using telco to connect the AI, and the AI learns with the diversity of the data, and the volume of the data will get closer and closer to Tesla's huge brain, because connectivity is universal. Next page, please. So future networks need to learn and need to grow, and that connectivity brings that learning capability. It is the basic principles I mentioned is like we design, or is like a baby, and then baby grows and learns and matures and become more intelligent. Whereas if AI doesn't have quality and diversity of data, it will grow, but it's like a baby still. And that is the picture I try to highlight on the right-hand side. So connectivity is extremely important to intelligence of AI technology. Next page, please. So what is AI can do for telco? Previous slide was telco can do for AI. Now AI for telco provides you person-specific personalized services based on the interest of each individuals. So adaptive user experience. It can auto-evolve services and applications. It can do auto-connected resources autonomously and more intelligently, provides resilience, provides augmented workforce, and also provide an AI native infrastructure, adapts to value creation and intelligent era and broadband and etc. for the network management and network control autonomously. So AI can do a lot for the network as well as network can do for the AI. Next page, please. From the user's point of view, user equipment or devices with artificial general intelligence, it can provide more personalized agent and more personalized services, which can do things on behalf of the user with the permission of the user, of course, but more intelligently. Next page, please. And also sensing as well as AI, I mentioned before, it gives an eye to the network. So network, like for example, radio access network, it can see its surrounding. It can see objects, movement of objects, where the traffic is, where traffic is moving to, and etc. And that is building a physical world model of the radio environment around each access point as well as the whole network. Some people refer to it as AI generative RF model, or they call it digital twin or digital cousins or whatever it is. But this is what sensing brings. But nevertheless, this sensing information, it not only gives the in-depth picture of the surrounding of the wireless and gives an eye to the network, also it helps AI, and AI helps to data analytic and extracting intelligence out of the sensing as well, together with the point cloud computing. So sensing and AI go hand in hand. We should not look at them as separately. Thank you very much. And next one, please. So now we come to the future use cases. We're going back to the teleportation. So with that background, I gave about 6G, AI, sensing, and etc. So one of the promises of 6G is real-time interactivity between and within virtual and physical world. Some people refer to it as like a digital twin and digital cousins and etc. But we want to extend this idea to how we can do teleportation. Next page, please. So let me show you the importance of the time synchronization. If Lily, if you go to 50 seconds, if you move the video to 50 seconds. Okay, thanks. Here we demonstrated, we had a demonstration, two people, different parts of our center and institute, they want to interact in a cyber world. in the cyber world. You see, the lady is trying to push the guy, and as you can see, there is no time synchronization here. And it is very unnaturalness. And if we do time frame synchronization, the real-timeness and the naturalness becomes very obvious. So this was, thanks very much. We can go to the next page. That shows that we need time synchronization. This was between two people. Just imagine it was between 3 people or 4 people or 10 people. So low latency is not sufficient. We need time synchronization between all these, as well as edge computing, in order to synchronize all this interactivity in physical world and cyber world, and within and between the two. So this time synchronization or teleportation I mentioned, which I will extend that one later on, it is not just for entertainment. It will revolutionize most of industry. Most of industry, or industry 4.0 that we know in 5G, it would elevate all of these to more real-time interactivity, like a driverless cars, cooperative driving, interactive cooperation and manufacturing, interactive agriculture, entertainment, interactive health, remote education, and many, many, many different aspects that we identified in 5G, but it will take it completely to new, the new dimension and new real-time interactivity. So time synchronization is important. So how can we do, based on everything I said so far, how can we do teleportation? We talked about we need imaging, we need localization, and we need 5 human senses to transmit. We need ambient information, as well as time synchronization. If we bring all of these together and integrate them efficiently, we will enable the teleportation. Doesn't matter where you are, when you teleported somewhere else, if it feels as if you are in that location. And you can interact, you can hug people, you can shake hands with people, you can have meetings as if you are there in body with the virtual reality. Next page, please. So what are the technical requirements for this teleportation? From early studies that we have done so far, time synchronization that we need, for example, for video frame, like interactivity, we thought that the synchronization within one video frame would be sufficient. So it is not a very hard technical requirement. The most difficult one is high quality, full body virtual reality transmission of that. That, for the high quality, it will require hundreds of gigabits per second. So that is a big challenge to do. High accuracy geolocation, we need sub-centimeter or millimeter accuracy with a very low jitter in this positioning. We need to capture ambient senses and integrate them into the environment and using like semantic data, semantic information. Another aspect is touch. Touch is the most difficult and complex of human senses to be captured and to be transmitted. So our initial investigation has shown that for every square inch of our hand, for example, we need 20 to 50 megabits per second data to be transmitted. So for one normal size, average size hand, we need about 1 gigabits per second. And the latency is not that low, and we require something like less than 100 milliseconds. latency. But what we realize, in order to reduce, we have ongoing research, in order to reduce this high data rate, touch, etc., combination of seeing, like a video, hearing, like audio, it will help to reduce the data rate that you need for touch. So a combination of that one would help each other rather than each of them individually to reduce the data rate that you require. Smell and taste are more chemical reaction, and the data rate that you require for that one is in order of tens of kilobits per second. So it's not a big technical requirement is there, but they complement each other. You cannot have taste without smell and a smell without taste. So the combination of them are more important. Next page, please. So we said that the virtual reality full body of a person, an average size, it requires hundreds of gigabits per second. But there is a emerging technology, it's called semantic communication, and we are working in that area. For example, if you have video H.265, we need 51.8 kilohertz to transmit bandwidth we require. With the semantic, we managed to reduce that bandwidth requirement to 1.6 kilohertz. So it's more than 20 times more compression that we can we achieve with the today H.265 technology. It's about it's about 3% of the normal video. And as you can see, if you run this one, the quality that we get at 1.6 kilohertz bandwidth is very similar to the quality we get for 265. Next page, please. Next page, yeah. And then we tested this idea in real wireless domain with a fading, with a mobility, and look at different modulation, different coding schemes, and etc. And what you see on the left-hand side is the state of art, and our solution is on the right-hand side. So we can maintain that quality at 1.6 kilohertz bandwidth, which is substantial compression with 3% of H.265, and more importantly, at a very low signal-to-noise ratio, which is 1 dB. So this is ongoing research, and there are lots of promises to reduce that technical requirements for virtual reality and augmented reality to substantially less bandwidth and less power that we require. This is the ongoing research. So there are techniques and technology either emerging or already we have it in place. Thank you very much. Next one, please. Okay, let's go back to huge brain again. For huge brain, turning the Earth into a huge brain, we need universal, intelligent universal coverage. Next page. For 6G, we need to look at unification between space or the mega constellation satellites and terrestrial networks, so that, next page please, so that all the users use the same terminal or same device to connect to satellite, to UAV, to high altitude platforms, or the terrestrial networks. And this is ongoing research in unification between the space and terrestrial networks, and direct to handheld and direct to device. So the device could be a vehicle, for example, and handheld, it could be a pocket-sized mobile phone that you have in your pocket. So this is part of ongoing 6G and will happen by the time that we see 6G in market. And we are researching in this area as well ourselves. Next page, please. So we need to look at all these space and terrestrial networks and integrate them into with AI, as well as a cloud native platform, so that the resource management, the network management, network control, mobility management, traffic steering, everything can be done as intelligently as possible within this three-dimension network of networks that 6G promises. Next page, please. So let's summarize. I said in TEDx 10 years ago, and how we can do teleportation. And Nikola Tesla said about nearly 100 years ago how the wireless connectivity, if perfectly applied, can turn the whole Earth into a huge brain and provide instant and irrespective of the distance connectivity. So what we need is look at technologies that we can transmit all the human senses. Well, at the moment, we are transmitting 2 of the human senses, and we need to look at technology to transmit touch, taste, and smell, and add them to hearing and seeing. We need to be able to capture, we should develop technology to capture as realistic as possible ambient information. And we need connected AI so that becomes over the time more artificial intelligence, general intelligence, to improve the intelligence of the network. We definitely need AI as well, and connected AI. Technologies like semantic and goal-oriented communication in order to reduce the bandwidth and energy consumption of bandwidth-hungry virtual reality, augmented reality, three-dimension video. We need to utilize this sort of technology in order to do that. We need accurate time synchronization in order to enable real-time interactivity between physical and digital world, and within digital world, or etc. It doesn't have to be only human, but it can be robots, and it can be cars, it can be any other entities that they need to interact in physical and digital world. We need, I put here sub-centimeter position accuracy. We already have a technology to do that, but that over the time we need to do sub-millimeter or order of millimeter position accuracy. We need wearables. We need wearables, so the current devices that we have, like a mobile phone, it will be an integral part of the future devices that we communicate. And we will be wearing these devices. And these devices, we need flexibility, and we need wearable electronics. And there are some promising new material is being researched on. One of them is topological insulators, which helps with energy efficiency and low latency, which enables analog computing rather than do analog digital and digital to analog and computing. That would help to speed up more energy efficiency and computation and efficiency, the AI and related AI, as well as semantic computing, as well as the wearables for capturing the senses, for transmitting, for sensing, as well as for actuation. We need both of them in this. When we have this intelligent world, sensing with AI and fully connected world, we need to pay more attention to privacy and security, especially the privacy of people's data, because effectively all the information that the people have, it is sensed and it is stored and it is analyzed, and it needs to have more. We have need to a technology that makes sure the privacy is preserved. To enable this teleportation, we need experts from different domains. It's not only just wireless engineers, but also we need people from material, we need people from computer science and chemistry, as well as the regulation and etc., privacy, security, etc. And also we need, for Tesla's huge brain to happen, we need a universal coverage and that unification of space and terrestrial networks. Next page, please. Thank you very much. I hope you enjoyed this lecture, and I'm happy to try to answer if you have any questions.
Thank you so much, Professor, for this brilliant lecture. And we have collected several questions, and I like to represent our audience in the live stream to ask the questions for you. The first one would be, what is the most significant bottleneck you foresee in moving from the theoretical framework of teleportation to its practical implementation?
Yeah, I hope my slides, the last slide I mentioned, I highlighted the bottlenecks and the problem. For teleportation itself alone, we found the most difficult one is touch. Touch is very complex. It's not only just pressure and temperature, but also texture that we need to capture and transmit. So we have some ongoing research we are doing, and we managed to transmit touch. And we found that when we have a combination of audio, video and audio and electronics to capture the touch, it will enhance the touch feeling, etc. So, and it is a very early stage of research, but we need to continue this one to capture the most important human sense, I think, is touch. And another barrier, I would say, we need new material. We need new material for computing and for being able, flexible and wearables to enable this. And the traditional way of we have been using a mobile phone in our pocket and etc., it would be more sort of like wearables, could be in form of glasses, in form of gloves, or whatever, in order to be able to capture the touch, taste, and smell, and activity, and etc.
Thank you, Professor. And then the second question is, what new industries or applications do you believe will emerge as a direct result of this teleportation technology?
I believe that the care industry, like telecare, like medicine, etc., it would be revolutionized. People do not need to go to hospitals. You can do this. You can meet your doctor remotely, as if you are in presence of a doctor. This is a very simple, quick answer to one of the question. I believe the manufacturing will be revolutionized. Doesn't matter where you are in the world, you can build things together remotely and cooperatively. I believe that driverless cars and autonomous driving, that when we have a time synchronization and we have the virtual reality, etc., that would change the way the transport is. The teleeducation, I know I'm in university professor, that people do not need to be present in the classrooms or to go to different countries to do that. You can get education as if you are in the same classroom, and you can interact with your classmates as if you are in the same place, as well as with the teacher, etc. So I believe that would revolutionize and transform many of the industry that we see now. 5G helped more industrialized and automation of the many industry, and will do that. I think teleportation and 6G will take it completely to new level.
Thank you, Professor. And last but not the least, given these innovations, do you see 6G as an evolutionary step or as a revolutionary shift that fundamentally changes the purpose of communication itself, from data transfer to teleportation, as you've described it?
Yeah, no, that's a very, very good question. And this is the question that, because we work with our industry partners, and that's a question that we've been asking our industry partners. And we decided, I share this with you, there's a new strategy that's been published on our website that you can see that, and it encapsulates and answers this question, this very important question. We said in 2025, we cannot decide, and we should not say that 6G will be evolutionary or revolutionary. We need to develop technologies, we need to develop the standards. In 2030, we compare evolution towards 6G from 5G Advanced, as well as clean slate approach, revolutionary approach. If the performance gap between the two in all these things that I mentioned is huge enough to justify the investment, then 6G will be revolutionary. If it's not, industry will not invest in that, and then 6G will be an evolution from 5G Advanced. So very briefly, 2025 is too early to say 6G will be revolutionary or evolutionary, but I would say us as a researchers, we need to innovate. We need to push the technology to its limit as much as we can, and look at futuristic technologies, and then we see what we have on the table, and then that would decide whether 6G will be evolutionary or revolutionary.
Thank you so much, Professor Rahim. I think that's all the questions we collected today. And for our audience, if you have any further questions, please feel free to leave the question in the comment zone, and we will pass it to Professor Rahim. That's all for today. Thank you again for participating at Chat Spark Hour. It's a great and fabulous lecture. And thank you so much. We will see you next time. Thank you. Bye.
Bye.
数学是最赤裸裸的东西，它直接告诉你一个事情的一个现象的本质，背后的本质是什么。
And mathematics is really something that